This video is a continuation of section 3-2, measures of center. Last time we looked at the mean and the median in the first video, and this video is going to explore a couple other measures of center, and we're also going to look at how to use the calculator to calculate some of these measures of center. So I'm picking up on page 4 of the note-taking guide, and this video will cover pages 4 through 6. So similar to the distribution problem we looked at before, this owner of some coffee shops along the highway has stores at mile marker 2, 4, 16, 28, and 50. All right, and she is looking for a place to put her distribution center. Now this problem is a little different in the fact that this store owner has 2 semi-trucks that have more than enough room to store all the coffee they need. So she is looking for some place to put this distribution center. Let's say she puts it here. All right, and she will have one truck that will drive to the west, drop off some coffee, then keep driving, drop off some coffee, and then keep driving, and then turn around. All right, and then another driver that will service these stores to the east. So this driver might come here, stop, drop off some coffee, and then continue all the way out here, then turn around. So we want to find where we should put this distribution center so that the driver that goes to the west would drive the same distance as the driver that goes to the east. And you guys looked at this last time in class, and you discovered that this should be at mile marker 26. All right, and if we put it at mile marker 26, this distance here would be 24, and the distance to the west would also be 24. All right, so this point that you found, this is the midpoint between the minimum and the maximum, and we had a special name for this. This was called the mid-range. All right, and just like we did before, we can look at that case. Well, what happens when we add this store way out here at mile marker 500? Is that going to affect our distribution center? Well, in this case, it most definitely will, because we are way out here before my distribution center was at mile marker 26. All right, but now I want to be halfway between 2 and 500, and you guys found that that was way over here somewhere at mile marker 251. So yes, we had to move our distribution center all the way down here. So we saw that unlike the median, the mid-range was affected by this outlier. So in summary, the mid-range of a data set is the measure of center that is the midpoint between the maximum and minimum values. So in order to find this mid-range, I'm going to look halfway between, or take the mean when I only look at the max and the min. So I'm going to take my minimum value plus my maximum value, and then I'm going to divide by 2 because I only considered 2 data here. So that you can think of it as the mean of the max and the min, or the midpoint between the maximum and minimum. So although the mid-range is very easy to calculate because I only have to consider 2 data, it is very susceptible to the influence of outliers. All right, because this measure of center only considers our maximum or minimum. So if we have an extremely small or large value here, that would clearly influence the mid-range. So now looking at example 6. Suppose we know the mid-range is 55 and that the maximum is 100. What is the minimum value? So just like the other problems we've looked at, we can take a more algebraic approach and we can also do this kind of more intuitively. So here on the left, let's start with our algebraic method. So we know that the mid-range is going to be the minimum plus the maximum over 2. Alright, well here we're given the mid-range is 55, so I know that this is 55. Alright, and our maximum value here is 100. Alright, so we could use some algebra here to solve for this minimum, which we do not know. So if I say 55 equals the minimum plus 100 divided by 2. Alright, so think back to algebra. I want to solve here for the minimum, so I want to get rid of this 2 here, so I'm going to multiply both sides by 2. So that would cancel these guys out. So then I get 110 equals the minimum plus 100. Alright, so now I'm going to solve for the minimum, so I want to get rid of this 100 here. So I'm going to subtract 100 from both sides. Alright, so then I get that the minimum value here is 10. So we could also do this more intuitively. Let's think of our picture here. We know the mid-range is going to be halfway between the max and the min. Alright, so I know my maximum is 100 and my mid-range is 55. Alright, so if I went here from my mid-range to my maximum, this distance here is going to be 45. Alright, so if I went 45 up to my maximum, I need to go 45 down to my minimum. Alright, so then 55 minus 45, that would give me a minimum of 10. So either way we can come to the same conclusion. Alright, the next measure of center we're going to explore here is the mode. So the mode of a data set is the value that occurs with the greatest frequency. That is the value that occurs most often. So unlike our other measures of center, the mode is not necessarily unique. So what do I mean by unique? Maybe you don't have a mode. Maybe your data is bimodal. Bi meaning 2, so this would be I have 2 modes. So maybe 2 values occur with the same frequency, or it could be multimodal. So this is many modes. Alright, so if I am considering the mode, now would that be affected by a single outlier? If I am interested in the value that occurs most often. So the mode is not affected by a single outlier. So suppose you poll the class on each student's favorite color. Which measure of center would be most appropriate and why? So, well, let's start with our mean. Alright, if I wanted to consider the mean, I would have to add everyone up and divide by n. Alright, well, how can you add up colors? Well, I can't, right? What's blue plus green? That doesn't make sense. So this guy did not work. Alright, the median here, well, I'm going to need to arrange everyone in increasing order first so I can find the middle value. Well, I can't order colors. Who comes first, green or blue? That one didn't work either. Alright, then we had our mid-range, which was the minimum plus the maximum over 2. Alright, so what's my minimum color? Well, again, no, we can't order colors, so this wouldn't work either. Alright, so the measure of center that would work here would be the mode. Alright, because I can get frequencies from each person's favorite color, and the reason that the mode would work the best here is because I can't add or order colors. Alright, so you can think of colors as categories, and we're going to come back to this later, but colors are categorical data, so we cannot add or order them, but we can see which one occurs with the greatest frequency. So the mode would be most appropriate here. Alright, one more measure of center that we want to explore, which I don't think your book goes into great detail about, is the trimmed mean. Alright, and the trimmed mean, I want to calculate the mean as we did before, but I don't want to consider the maximum and minimum values. So if you think about the trimmed mean, think about the Olympics when they are scoring, maybe I think it might be gymnastics or diving, and maybe one judge might be partial to her or his own country, so the way that they try to correct for that possible outlier is they throw out the maximum and they throw out the minimum value and then take the mean of what's left. So our trimmed mean here alright, well, I'm going to add up all my values like I did before, but now I don't want to consider the maximum or minimum. So I'm going to subtract off the maximum, and I'm going to subtract off the minimum, and then instead of dividing by the total number, now remember I threw out the max and I threw out the minimum, so I'm going to divide by 2 less than the number, because I don't want to consider the 2 that I threw out. So this trimmed mean attempts to correct for the effect of a single outlier. So I'm going to throw out my largest value, throw out my smallest value, and then take the mean of the remaining value. Alright, so next I want to look at how we might use the calculator to find some of these measures of center. Now on page 6 in your note-taking guide, last time we collected data regarding your pulse rates. So each student recorded his pulse rate, and we collected these data at the top of page 6. Now for this video I'm going to use the data from your book, and this is on page 47 of your book. To use the calculator here, I'm going to hit the menu button, run matrix menu. This is where we would add and subtract and whatnot. We used that last time. We want to go to the statistics menu. So you could either move the highlighted box to number 2 and hit execute, or a shortcut, this is number 2, so I could just hit the 2 right here. So here we're given a number of lists. Now what I have already done, and what you can do now, is pause the video and enter the data that you collected last time into list 1. So you might do this, you would type, your first data and then hit execute. Then hit your second datum and then hit execute, and so forth. So go ahead and pause the video and enter your data from the top of page 6 right now. Okay, I'm going to assume that you have your data entered there. So now that I have all these data in list 1, we want to calculate our one variable statistics. So I'm going to go to my calc menu because I want to calculate. Alright, I want my one variable statistics, but just before we go there I want to make sure everyone is set up correctly. So I'm going to go to F6 to set up my one variable statistics, and here it says one variable X list. Well, that's where did we enter our data, and we entered them into list 1, so that's set correctly. Down here we have our one variable frequency. So sometimes we might enter values into list 1 and their frequencies in another list, but here each value occurred once, so I'm going to put a frequency of 1 there. Alright, so once you have those set up, our two variable statistics, we will come back to that at the end of the course, but for now our one variable statistics are set up correctly. So I'm going to exit back to the screen we were just on, and I can hit F1 for my one variable statistics. So here we are given a good bit of information. This X bar, if you remember, is our mean. Okay, sigma, capital sigma here was the sum of the x's. So if I added up all of these pulse rates right here, I would get 3,052. The sum of the x squareds, we're not going to use that right now. The sigma and sx, these are our standard deviations. We're going to come back to these later. All right, n here stands for the number of data. So there were 40 data. We have the minimum value of 6. Q1 we're going to come back to later. The median value of 74. The maximum value of 124. And here we have a mode of 72. Now here we say mode n equals 1. So this is telling us the number of modes that we had. Remember we said the mode is not necessarily unique. So maybe there were 2 or 3 modes, but here we only had one mode. And this f equals 8, this is the frequency of that mode. So 72 occurred 8 times in my data set. So just to annotate your notes so we can remember what these stand for here. The x bar, as you remember, is the mean. Okay. Sigma sub x is the sum of our data. Alright. And these guys that I'm not interested in right now, we're going to ignore these guys. We'll come back to those when we talk about measures of spread. But for right now, n is going to be the number of data. Alright, and then we're going to have our minimum value. And then MED stands for our median. Alright, and you might remember in our notes we used x tilde for the median. However, the notation the calculator uses is MED. Then we have our maximum. Alright, over here we have our mode. Alright, and then where it says mode n, this is the number of modes, because perhaps this might not be unique. And here we have the frequency of our mode. Alright, so we can find the median is given here. Next we talked about the mean, which is given also, x bar. Alright, then we talked about the mid-range. Well, the calculator doesn't give us the mid-range exactly, but you see the calculator does give us our minimum and our maximum. So if I wanted to find the mid-range, well, I know what my minimum is and I know what my maximum is. 60 and 124. So I could go to my run menu and I'm going to say 60 plus 124 and then divide that by 2. So it gives me all the pieces, but I might have to take one more step here. Alright, so next we talked about the mode, which is given in the calculator, and finally we talked about the trimmed mean, which the calculator doesn't give us the trimmed mean exactly, but we could calculate this. So let's come back here. I'm going to flip back to the trimmed mean. So the sum of all my x's, this piece right here, Well, now I know what that is. That is 3052. Alright, my maximum is given to me here, which is 124. And then my minimum was given to be 60. And then in here, I now know this is 40. Alright, so if we wanted to calculate this, I could say, well, my trimmed mean here is going to be 3052. I'm going to subtract off the max, subtract off the min, and now I'm going to divide by not 40, but 38. So I'm going to go to my run menu, and 3052 minus 124 minus 60, and now I want to divide by not 40 but 2 fewer, which would be 38. So my trimmed mean here would be approximately 75 and a half. So I'm going to do approximately 75 and a half. So that's how we might use the calculator to find some of these measures of center.